For centuries, humanity has looked toward the sky in search of answers, building theories, writing equations, and trying to understand our place in the vast cosmic puzzle. Our understanding of physics, cosmology, and the nature of space and time has been shaped by generations of observation and discovery. But what the James Webb Space Telescope has recently observed has challenged many of those assumptions. It has revealed galaxies that appear surprisingly mature, planets that are difficult to explain with current models, structures of unexpected complexity, and observations that continue to raise new questions about how the universe evolved. This is more than just another astronomical discovery. It represents a confrontation between long-standing scientific models and new observations that demand deeper investigation. If these findings are confirmed and fully understood, they could reshape parts of our understanding of the universe. Rather than providing final answers, Webb's discoveries are opening new doors, encouraging scientists to rethink ideas that were once considered well established. During a series of deep-field observations, the James Webb Space Telescope captured some of the most detailed images of the distant universe ever recorded. Hidden within those breathtaking images were features that immediately caught the attention of astronomers. In the galaxy cluster Abell 2744, researchers observed unusually aligned sources of light and structures whose arrangement appeared remarkably ordered. In the spiral galaxy NGC 1365, Webb also revealed unexpected patterns in the motion of gas and stars, prompting scientists to investigate whether existing models of galactic dynamics fully explain what is being observed. The surprises did not end there. Similar unusual features began appearing in multiple observations. The farther Webb looked into the distant universe, the more complex the cosmic landscape appeared. Across billions of light-years, astronomers found structures whose organization seemed more intricate than expected. While some of these patterns may ultimately have natural explanations, their repeated appearance has inspired researchers to explore whether hidden physical processes are influencing the large-scale structure of the universe in ways not yet fully understood. Among Webb's many targets was the exoplanet HIP 65426b, located hundreds of light-years from Earth. What Webb revealed about this distant world quickly attracted scientific interest. The planet has a mass estimated to be about 7 times that of Jupiter and orbits its young star at roughly 3 times Neptune's distance from the Sun. Even more remarkable is that the host star is only about 15 million years old, a very short time in astronomical terms. According to traditional models of planetary formation, building such a massive planet at such a great distance from its star within so little time is difficult to explain. No obvious protoplanetary disk remains around the star, and astronomers continue investigating how a giant planet could have formed and remained in such a stable orbit. Some researchers have proposed alternative formation scenarios, including the possibility that the planet formed elsewhere before migrating outward or through mechanisms not yet fully understood. At present, however, no definitive explanation exists. HIP 65426b remains a fascinating world, glowing at temperatures exceeding 1,000 degrees Celsius while orbiting a system that appears remarkably young. One of Webb's most visually stunning observations involved an Einstein ring, a phenomenon produced when the gravity of a massive foreground galaxy bends and magnifies the light from a more distant galaxy directly behind it. Around the galaxy J0148, Webb captured an almost perfectly complete ring of light, displaying an extraordinary degree of symmetry. Although gravitational lensing is a well-understood prediction of Einstein's theory of general relativity, perfectly aligned Einstein rings are exceptionally rare. To produce such an image, the foreground and background galaxies must line up with extraordinary precision across billions of light-years. The remarkable symmetry of this observation has inspired astronomers to study it in greater detail, not because it challenges known physics, but because such nearly perfect alignments provide valuable opportunities to investigate dark matter, galaxy evolution, and the geometry of spacetime itself. Perhaps the discoveries that have attracted the greatest attention involve extremely distant galaxies observed only about 180 million years after the Big Bang. Webb has identified galaxies that appear brighter, more massive, and more evolved than many cosmological models had predicted for such an early period in cosmic history. According to the standard picture of galaxy formation, the earliest galaxies gradually assembled over hundreds of millions of years as gravity pulled together gas and dark matter. Yet some of Webb's observations suggest that certain galaxies formed stars and accumulated mass much more rapidly than expected. These findings have prompted cosmologists to refine their models of how the first galaxies grew, rather than abandon the Big Bang itself. The observations suggest that the young universe may have been capable of producing complex structures more efficiently than previously believed. As researchers continue analyzing Webb's data, these distant galaxies remain one of the telescope's most important scientific puzzles. They are encouraging astronomers to explore new ideas about early star formation, galaxy mergers, dark matter, and the physical conditions that existed shortly after the birth of the universe. In another intriguing observation, Webb detected evidence of a gravitational lensing effect in a region of space, where no obvious visible object appeared capable of producing it. No bright galaxy, prominent cluster, or easily identifiable source of mass was immediately apparent. Discoveries like this often lead astronomers to investigate the possible presence of extremely faint galaxies, large concentrations of dark matter, or other massive structures that remain difficult to detect directly. Rather than providing definitive evidence of unknown physics, observations such as these demonstrate why the James Webb Space Telescope has become one of the most important scientific instruments ever built.